Hello everybody, today we have a bonus problem called longest substring with k distinct characters. Original problem is on LeetCode, longest substring with at most k distinct characters. Given a string, find the length of the longest substring in it with no more than k distinct characters. Suppose that we are given the string ARAACI. We have at most two distinct characters. And our output is 4 because the longest substring with no more than 2 distinct characters is ARAA. Now, in this particular situation, we only have 1 distinct character, so we have AA. And lastly, with 3 distinct characters, we can grab a total of 5 items, which is CBBEB or BBEBI. So the most straightforward way of doing this is probably do some counting. But right now, we do need to consider some edge cases. What if k is equal to -1? Well, or 0, for that matter. Well, how shall we deal with these cases? Yeah, so if k is 0, that means there are 0 distinct characters. We should just immediately return 0. What if k is -1? Well, if k is -1, that is incorrect input, and we should return -1. A common thing during interviews is that we would exclude those examples and we would not even deal with them usually, and we would expect results of a certain type. We might not even have to deal with these edge cases. Another case is, what about an empty string? An empty string with a k of 100, right? Well, that's going to be still out return 0. Those are going to be our test cases, and I will write the test cases now, and we'll come back with matching. So just give me a moment, I will get those for you, and we'll be back. So hey there, we're back, and we have our test cases. Let's run it, and we should have some failing test cases. Oh, we did not run main. There we go, let's just run main. And we should have some failing test cases. This is going to be our review and our edge case understanding. So we have a couple fails, a couple passes already. Well, those might not be passing very soon, but let's get started. Let's talk about the time and space complexity that we're aiming for. I believe that we are aiming for a time complexity of O of n. That's just what I think. And a space of definitely O of 1 because we're returning the number of items. We may use more than that. We don't know exactly what we'll be using, so I'm just guessing here. So our match is that we do need a hash to retain the number of items that we have. So that brings our space up from 1 to already n. So that's we need that hash so that we can hold each particular item and find out how many items we have in our dictionary. If we have more than our current items in our dictionary, we should definitely lose the items. And we're going to use a sliding window as well because I think a sliding window would work very effectively here because all we need to do is look at our item, right? And look at our dictionary. So let's say we have our item. This is going to be our plan. Right, we have our item, we have I. This is our sliding window. This is our left, and this is our right. Let's cancel that. Give me a moment. I'm gonna shut down my. All right, I shut down my autocomplete. Let's get started. So we have our A, and let's add that to our dictionary. We have 1A at this point. We move the right, and we have an R. So now we have 2 distinct characters. We have 1 of them, and we keep moving. So now we have another A, so we have 2 A's. We still have 2 items. Now we have 3 A's, 3 items, right? Now, by the time we get to the 4th item, so at each particular point, we will increase our max length equals max of max length. and R minus L. At this point, 0, 1, 2, 3. So R minus L is 3. We have a total of 3. And we do need a plus 1 to get the current spot. So we do that. With that, we can move forward again with R. And we are at C now. So now C is going to be at 1. And so what happens is that while the dictionary, it has more than k items. So remove L and remove item from dictionary. So we move L, we remove an A, so that's remove an item. Then we move L again because we removed R. And so now we have 0 items in R and we delete that item, right? So now we have A and C. So we have 2 items again. So we can check our new max length again. So this happens while R is less than the string, length of string. Because we're going to go through the entire length of string. So we go to I, and I is 1 now. And we keep moving the L until we lose A, basically. And now we check this length when we lose A. Check max length, right? And then that way we can have the max length of the longest substring in k distinct characters once R has reached the end. And that's it. So that's our code. I think we walked through the code pretty okay. That's how we created our plan. And we are ready to code. Let's do it. I'm sure that there are better ways that we can think about. Let's do that after we have completed one run, and then we'll think about more. So let's create a left and right pointer. Let's do a while loop. While R is less than the length of S, right? Let's keep moving. And, oh, we do need a hash map, right? Hash map equals dict. And we are going to start inserting items one at a time. So if R not in hash map R plus equals 1, else hash map R plus equals 1. If length of dictionary is greater than k, then we need to remove the item from our hash map. So length plus equals 1. Let's set the length at 0. So we added an item to our hash map. That means our length is now 1 longer. No, that doesn't make any sense because we have R, L, and R. So we should just set max length. My bad. Just give us the max length, and we'll check that at the end. R minus L plus 1, right? What we're going to do here is if it's longer, then that means we have to remove an item and L plus equals 1. So length of our hash map is greater than k. Hash map is going to at this particular point, let's say L. L is going to be our S of L, and R is S of R. So let's just make sure that that's what we're doing. Okay, great. So S of L is going to be minus equals 1, right? And if equals 0, we can delete this character and we will be on our way. So now we have R minus L plus 1. With that, I think that follows all of our plans. Remove item, check. That's it. I think we're missing one thing, and that is to do it R plus equals 1. So R plus equals 1 at the end, so that we can reach the end of our items. So with that, we are good to go. So let's return max length. Hopefully we have this pretty okay down packed. And now we have a key error. So what does that mean? So we tried to remove an A, but it was non-existent. And that's why we were greeted with a error. I don't think that was supposed to happen, because with the deletion, this should be less than k. Oh, my bad. It should be a while loop too. My bad. And we did not increment our L. So let's try that one more time. I believe we have the same error this time. So we have another B error because, well, that wasn't supposed to happen either. So what's going on exactly? Why is this happening? I'm not sure. I'm gonna take a look at this. So I added a print statement and everything was looking good. It was the -1 case that was causing the error. So let's take care of that -1 case. So if k equals -1, this is less than 0, return -1. So let's run it again. And everything's returning true. Perfect. So just a little print statement. Logic was good. And we were able to complete this problem. No problem. How can we improve this code? I think there are ways to improve the code, but currently it reads perfectly fine. Next time we read it, maybe there will be different things that we don't notice and can be written better. But right now, I think we're looking good, and that's it. That's all we're gonna do. We have done our test cases, and we have done it in O of n time because we went through it with a 2 pointers, a sliding window, to be exact, and we went through it only one loop. So our evaluation of this code is O of n time and O of n space, depending on how much. It's O of k actually. So O of n time for each character in string, and it's a O of k space for each character stored in our, what do you call that thing? Our hash map. It's actually k plus 1 because we're storing more than k, one more than k, and then we'll be removing it shortly afterwards. With that is our evaluation, and that is our code. I hope you enjoyed this video. If you enjoyed this video and you learned something, like and subscribe, and I will see you in the next one. Thank you. Bye.